Is today going to be a memorable day for you? How will you remember this time of your life once you go back home? When you're describing it to your friends over the weekend? When you sit one day as a doctor or a scientist thinking back about your time at the Canadian Medical Hall of Fame all those years ago? Let's take a trip down memory lane. Memory is our ability to remember past experiences. It is essential to how we learn because it lets you store and retrieve information that you learn. For example, you learn a new language by studying it, but you then speak it by using your memory to retrieve the words that you have learned. Now, memory comes in different flavors. Your eyes, your ears, your skin are all passing information from your environment to your brain. Your eyes see a face, your ears hear a song, your skin feels soft snow falling on your face as you walk down the street. This information from our senses, known as sensory memory, lasts a second or two and is quickly converted to short-term memory. Short-term memory temporarily records all information around us, but unless we make it a conscious effort to retain it, it disappears quickly. It lasts, on an average, 30 to 60 seconds. So how do we actually remember things? Or specifically, how does short-term memory become long-term memory? Remember that part about making a conscious effort to retain short-term memory? If you're learning a song on a guitar, you better practice it over and over again until you can play it on your own without the need to look at lyrics or the notes. With practice and effort, you will convert short-term memory into long-term memory, and that happens with most things in life. Long-term memory stores all sorts of information. Your parents' birthdays, the meaning of the word snow, song lyrics, what you ate last night. It also helps you remember how to do things that come automatically to you, like riding a bike or tying your shoelaces. Some things we remember for a long time, days, months, years. Some things we never forget. But remember, we don't always remember things exactly as they are, and as we age, memory becomes less reliable. Now that we know a bit about the different kinds of memories, your next question is probably an obvious one. Where are memories stored in the brain? Short answer, all over. Right now in this room, your ears are capturing sound and sending it to a brain region called the auditory cortex, where a collection of nerves process and store sound. These sensory memories are going to the hippocampus, where they are being stored as short-term memories. The hippocampus is located deep inside our brain, somewhere in the middle. Now, are you finding what you're listening to interesting? If not, those memories, those sounds, will be gone within a minute. But let's say you do find it interesting. In that case, the hippocampus will convert this short-term memory into long-term memory and send it back to the auditory cortex, but with one key difference. The connections between nerves in the auditory cortex have now grown stronger, somehow retaining the sounds as long-term memory. So what did we learn? The hippocampus acts as a central sorting station of sorts for all sensory organs. Information comes in, and depending on whether we find it useful or interesting or not, gets converted into long-term memory and gets stored in different parts of the brain. Now let's say after our session is over today, you decide to walk back home. The roads you take, roads that you have walked on so many times before and could navigate with your eyes closed. All that spatial information that you have learned and memorized, all of it is stored in the hippocampus. What about how you feel? You'll probably feel relieved that the session is over, or happy because you're looking forward to a nice dinner back home, or sad because you won't see friends till tomorrow. Our emotions of any kind, joy, love, sadness, and memories that trigger it are stored in a brain region called the amygdala. Now, remember when I asked in the beginning if today's session was going to be a memorable one? What happens if you try and remember it? The hippocampus will, in a way, pull all sorts of memories associated with this day, the images you saw, the faces you remembered, the sounds you heard, the wind in your face, the conversations with your friends, the walk back home, the dinner afterwards, and whatever you were feeling that day. All of it will form an episode, much like a Netflix show, and play it back in your brain. The hippocampus is also one of the brain regions most affected by Alzheimer's disease. People suffering from Alzheimer's have trouble creating new memories and often forget dates and important events. They don't recognize friends and family anymore. Eventually, they forget basic things that they've learned from childhood, like tying their shoelaces and how to chew and swallow. Remember, the more we learn and experience things, the connections between neurons get stronger and stronger, and these connections are stored as long-term memories. In Alzheimer's disease, connections between neurons get weaker as we age, and the neurons themselves start dying. The very things that help form and store memories in our brain start breaking down. The disease is always fatal, and we still don't know what causes it, and there are no treatments available. But can be prevented. Doctors recommend staying mentally and physically active. Do crossword puzzles, learn a new language, keep physically active. We do know that mental and physical activities keep our neurons healthy and connections between them strong. Now you might be wondering, how does all this information relate to the Canadian Medical Hall of Fame, or CMHF? Did you know that 2 CMHF laureates are responsible for discovering how memories form and the different kinds of memories available? Their names are Brenda Milner and Endel Tulving. In 1955, Dr. Milner was introduced to a patient known as HM. He had brain surgery to treat his epilepsy. While the surgery cured his epilepsy, it completely destroyed his brain's ability to convert short-term memory into long-term memory. Milner spent 30 years with HM trying to decipher how his brain worked. In the process, Milner discovered the different kinds of memories that we have and where they're stored. She also showed how we use our visual memories to understand more abstract things like words and their meanings. For example, when you see an apple, you automatically think of the word apple. Milner was one of the earliest researchers to explain the relation between what we see and what we think. Endel Tulving's work was similar to Brenda Milner's. While Milner proved the existence of multiple types of memories, Tulving was the first to think about and develop these ideas. 50 to 60 years ago, the idea that the brain had different kinds of memories and different parts of the memories stored different kinds of memories was considered revolutionary and considered wrong. Tulving's ideas and research changed that forever. Do you remember a few minutes ago when we were talking about how the hippocampus pulls memories from different parts of our brain into one big episode, like a Netflix show, when we try to remember important events in our lives? Well, Tulving was the first person to explain how exactly this happens in our brain. His work was also important in helping us understand Alzheimer's disease. Another thing before we end, Brenda Milner was doing pioneering, groundbreaking work at a time when there were very few women scientists, not only in Canada, but around the world. Let that seep in for a moment. We feel nervous when we have to introduce ourselves to a new group of people, and sometimes, no matter what we do, we are always made to feel different by others, or made to feel like an outsider. Imagine that pressure, and now imagine working in such an environment and putting in 100% of your hard work every single day to discover something that changes the way the world understands something. That takes courage. Brenda Milner, like so many women scientists around the world, was courageous and paved the way for women scientists everywhere.